In this very short video, I'm gonna show you how to optimize production and injection targets. So one might wonder, okay, what is optimizing the target? So if I have a producing well, I just need to set the bottom hole pressure as low as possible. This way I will have the most liquid production. And in an injector, I need to set the bottom hole pressure as high as possible, and this way I will inject as much as possible. But in real life, sometimes this way of thinking could cause problems, because let's imagine you have a two-layer system, and you perforated the target layer, which is saturated with oil, unit B, but you have an overlaying unit A, which is water saturated. So when you produce at a moderate pressure drop, you will have oil production. The next year you want to produce more. You reduce your bottom hole pressure, you increase your rate, and you still produce oil. But then at some point, when you reduce your bottom hole pressure furthermore, you will get a problem. And here is how the problem looks. If you increase the pressure drop, at some point the pressure between unit A and the bottom hole pressure across unit B will create the critical pressure gradient, which will break the cement, and you will have the behind the casing flow of water from unit A to the perforations of unit B. And that could be the problem, especially if your pump is not able to produce as much liquid. Then after this your bottom hole pressure will start to grow and your oil production will start to drop. So here's the model of this effect in the PetroCup simulator. We have a value of the critical gradient, which will create the channel in the cement. The value is given for each asset. It's different and can be seen in the data room. So it means that the optimal bottom hole pressure, let's say in a producer, would be more than the reservoir pressure in overlaying unit, which can be assessed with the formation pressure testing, minus the height between the layers, the thickness of a shale rake, multiplied by the critical pressure gradient. Let me give you an example of a channel. Like here is an example of a channel on our synthetic asset, which we see on a producing well. So this well number 19 has a channel from the overlaying water saturated layer. So we can see here clearly that we do have production from this layer while it's not perforated. It means that we have a channel which can be fixed, and it could be the way to optimize production. Another example is a channel in an injecting well. So here you can see that we have some water going into the target perforated layers, but then a huge amount of water is also going here below the perforated layers. And of course it's a thief injection, which also needs to be fixed. Then one might wonder, okay, even if I know the optimal pressure, but I need to set the rate on a well, how do I convert my knowledge of the optimal bottom hole pressure into the knowledge of rate? And that is where we have a Dupuy equation, which you see on the screen, and I really hope, guys, you are all familiar with this equation. It looks a little scary, but it can still be calculated, because all the information you do have in your data room to calculate your rates. But sometimes it's not even necessary, because most of this properties such as height, permeability, drainage radius, skin could be unitized as a productivity index. Because if you have more or less stable production or injection, most of these properties would be constant in time. And that means that you can actually study the productivity or injectivity index of your wells and use it in calculations of rate from the optimal pressure. And also you can assess your productivity using pressure buildups, pressure fall-offs, and of course the step rate tests, which are also available in the PetroCup simulator. That's it, guys. Thank you very much.